What's up, Flatline Nation? This is Andrew with Flatline Knives. Today we're going to talk about how I make my stainless clad SAN-MAI blades. I start off with a jacket of 410 stainless steel and a core of 1095. As with any kind of forge welding process, you want to make sure that all of your surfaces are super clean before you put them together. The trick to making this fuse well the first time is to use a strip of paper in between each of the layers of the billet and getting a nice, tight, clean weld all the way around every exposed surface of the billet. Now, be sure and take your time when you do these welds because they are very important. It has to be totally airtight before you throw it in the forge to prevent any kind of decarb or oxidation. Once your billet's up to temp, it's time to forge weld it. And you notice I'm taking very gentle passes on these first couple of welds just to make sure that everything gets set nice. I don't want to overstress it. These materials don't really like to bind, so it takes a gentle touch until you get it fully fused before you start to move it around too much. I also am really careful not to press it on end. One, because the welds haven't been ground off yet and I don't want to press those into the blade edge, but I also don't want to burst any of those welds. Once I'm confident in the forge welds, I'll take it to the drawing dies just to gain a little bit more length and width, and I also bring it down to the thickness I want to work with. Each of these pieces were 3/16 thick, and I want it to be a total 3/16 thick, so I use the drawing dies and draw the billet out and bring it down to the right dimensions. This is another perfect example of how to use a kiss block to your advantage. I don't want to over press it, so I use a kiss block that is slightly thicker than where I want to be in my final dimensions, and I just push it out of the way and have my 3/16 block right behind it, and I use the flatting dies to make it nice and flat and even across the whole face of the billet. Once I've got it flattened out, I'll take it over to the anvil at heat and try to brush some of that scale off. I learned that stainless steel is really resistant to grinding, and facing these off can be kind of a belt burner. So I brush off as much scale as I can, and then just give it one final flattening pass to make sure it's exactly the thickness I want. This is also my last opportunity to make it as flat as I possibly can. That way the core stays right in the middle between those two stainless layers. That way when you grind it, the edge material is all high carbon and it's nice and even. So this is what we're left with. It's got a little bit of a banana shape to it, and that just is the nature of how it's pressed, but that's okay. We can work with that. Now it's time to take it over to the angle grinder and make sure that all that weld bead is ground off of there, and this is the first time you really get to check to make sure that your welds are set all the way through. It's actually pretty cool to watch because as you grind it and heat up the billet, you can see the difference in color between the stainless jacket and the high carbon core. Obviously, once you take it to the ferric chloride etch, it won't even touch the stainless, so it stays really nice and white, and then that high carbon core gets really dark. You also can kind of start to see where some of the carbon migration occurred between the high carbon and the stainless, and it creates this really cool hazy effect. Once your blade is profiled, it's time to take it to the grinder and flat off the sides. Now, it's very, very important that you first take your billet to the tempering oven and anneal it in some way to make that stainless steel a little bit softer. You won't be able to drill through it if you don't, and it is a total pain to grind if you don't anneal it first. Once your profile is all profiled and your flats are all nice and flat, it's time to start working on bevels. I'm not going to go into too much bevel grinding technique. There's about 1,000 excellent YouTube videos you can watch if you're curious about this part of the process. Here all I'm doing is taking a 45-degree angle pass, bringing the center line to the line that I've scribed on both sides before I start working on any kind of beveling. Like I said, this is just one of many ways to do this, but I like this way because it gives me a chance to make sure that my blade edge is straight all the way from the ricasso area all the way out to the tip on both sides before I start doing any kind of beveling. It gives me a lot of leeway to make sure that everything stays nice and straight throughout the whole process. Another advantage to this technique is it allows you to set your plunge grinds to be really nice and crisp and even on both sides before you translate that across the entire face of the blade. Now that the blade edge is set, it's time to take it and start working on the bevels. Now, it's critical to make sure that you do an equal amount of grinding on each side of the blade, because if you don't, compound material forge welding like this can really cause your blade to skew one side or the other and can actually do some really funky things in the quench. So this is the opportunity to take extra time, make sure you do it right, and it will pay off in the end. Now it's time for the first peek to see where your edge is. And on this blade, I got really lucky. Everything is nice and even right in the middle on both sides. Now the bevels are done and get your pinholes drilled, it's time for the quench. For me, this is one of the most nerve-wracking parts of this entire project, because in the YouTube videos that I had watched on how to do this, there's a very real chance that all three layers were just going to fully explode and separate from each other and just create an ugly paperweight. But I got lucky in this case. The forge welds were strong, everything was nice and clean, and you can see I got a really nice martensite edge on that 1095. I was also fortunate in this project that I didn't get any kind of warping in the blade. It's a virtue of how thick it is, but I was also very careful to make sure everything was ground very evenly so that we wouldn't have to fix any warps in the temper. So now comes one of my most favorite parts in making a knife. It's been final ground, it's been hand sanded. I've taken a lot of care to make sure all the scratch lines are nice and even. And even in the hand sanding process, you can start to see the differentiation between the high carbon and the stainless steel. So we're going to dip it in ferric chloride. It's not going to do anything to the stainless steel, which is ideal. And it's going to bring a really nice dark pop to that 1095 core. And just look at how that 1095 core just jumps off the blade. You can see that gray wavy line right in between. That's that carbon migration from the 1095 into the stainless steel. Once the etching's complete, I'll use high quality oil to really set those oxides into the high carbon steel, and that'll help keep it dark over the life of the blade. I also wanted to make sure to etch the spine and the belly of the handle, because that'll add a tremendous amount of contrast once the handle material is on. So I went ahead and picked a really nice set of curly mango scales, and I glued on a red set of liners. I was hoping to have a really neat gradient of gray to solid color to light to black to light to red to gray as you move across the spine and belly of the blade, and I think it turned out really cool. Now, many of you have seen me do this trick before. I'll drill my holes one at a time, and after I'm done with the hole, I'll use a sacrificial pin to keep everything in line as I continue through the handle shaping process. Once all the pinholes are drilled and I got the sacrificial pins in there, I'll use my bandsaw and cut off any of the excess handle material kind of around the handle profile. It saves time and saves on abrasives. So here are the scales. They're all polished up. I make sure to polish the bolster area specifically, because once it's glued to the blade, it's almost impossible to get into that space and make it look nice and clean. And once it's all glued together, it's time for final handle shaping, and this is the completed knife for this project, and I'm super happy with how it turned out. The colors are there, the contrast is there. That carbon transfer from the high carbon to the stainless is one of my favorite parts about this whole knife. That, in combination with just the drastic contrast between the stainless and the high carbon, I couldn't be happier. Thank you so much for following along with this project. If you enjoyed it or learned something, be sure and leave a like and a comment. It really helps the channel out. Don't forget to subscribe if you'd like to see even more forging content, and be sure to follow me over on Instagram at Flatline Knives.